All right, so remember, whoa, wow, crazy. Remember, that's going to be weird on the video. Remember that rational expressions are just big fractions, right? So we're talking about adding and subtracting them. We got to talk about adding and subtracting fractions. We got to remember some of this stuff from back in 6th grade. Yup. You need to find common denominators in order to do this, in order to add or subtract fractions. Nuh-uh. Common denominators. So if you have this is literally throwback to 6th grade. 3/8 plus 5/12. Are they the same denominator? No. How do you make them the same? So you could try to divide, but remember, whatever you do to one half, you got to do the other half. I don't want to divide this by 2. Multiply it by something. If you don't know what to do, just multiply them by each other. That forces them to match, right? Yeah, as long as they match. Sure. Whatever you do to one part, you got to do to the other. So now it's 9 over 24 plus 10 over 24. Now the denominators are the same. Woo! Yay, 6th grade was so fun. Uh-huh. Arr. Whoa. Wow. Hey, what if you have this one? Are these denominators the same? No. How can you make a match? You could, but then you'd have to root this. Can you do something with this? Square it, or in this case, just multiply it by y, right? It's the same thing. That's the same thing as squaring. So just multiply it by y. And now do you need to do anything to this? No. So you don't have to do something to both of them as long as you can make a match. So this would be 3xy over y squared plus 2 over y squared. And now they're the same. What's 3xy plus 2? It's just 3xy plus 2. Because you can't combine these, right? This has an x and a y. This has nothing. So you can't combine them. Is this making a little bit of sense? Okay, then let's do some that are a little bit more complicated. It's this same idea. You're just getting common denominators. Let's do it with these. We're trying to get common denominators. So on this one right now, are the denominators the same? No. So when in doubt, just multiply them by each other. Okay, that's all you got to do. Multiply them by each other. I'm going to multiply this one by r plus 2. I'm going to multiply this one by r minus 2. But whatever I do to the bottom, I also got to do to the top, right? So this one gets an r plus 2. This one gets an r minus 2. You okay with that? Okay. So here's the deal, guys. I know that gosh, it's gonna kill me. I know that we just got finished. I know that we just got finished multiplying these things, and I told you don't actually multiply them because sometimes it makes things harder. But here, I'm actually going to multiply what's on top because I want to be able to combine stuff. in the end because I'm adding it. So I want to be able to combine some like terms. So I'm actually going to multiply what's on top. I'm not so concerned about multiplying what's on bottom because all I care about is that the bottoms match each other. All right? So now, does this match this? Yeah, so I don't care if it, like, you don't have to multiply it out. All I care about is that they match. So now, since they match, we're good. But I am going to multiply what's on top. So that's 4r times r plus 2 over this crap. Plus 4r times r minus 2 over that same stuff. Oh, hope. Aren't you, like, running for something? Oh. It's already over? Oh. Got it. All right, now I'm going to multiply the stuff that's on top. Oh, my gosh. This thing. I don't know how this works. I'm going to multiply the stuff that's on top, but not the stuff that's on the bottom because it matches and I don't care. I just want it to match. So it's going to be 4r squared plus 8r. Because I want the denominators to be the same. Are you guys okay if I just rewrite this as this? You know what it is, right? It's this thing. I just don't want to keep writing it. 8. You good with that? Oh. Oh, we're having a rough day. All right, hey, you're adding these, right? The denominators are now the same. Once they're the same, what can you do with what's on top? Just combine them. 4r squared plus 4r squared is 8r squared. 8r plus negative 8r, what's that? So it's 8r squared over this denominator. Does that make sense? Feeling okay? Okay. Do that one. Multiply them by each other. You don't have to multiply the bottoms. You just need them to be the same, but you do want to multiply the tops. Go down. So you want to get common denominators. You're going to do that by multiplying it by each other. Just multiplying them by the opposite denominator, yeah? Do you need to multiply them on the bottom? You could if you wanted to, but do you have to? No, because they match. So whatever, they're good. They match. You don't have to multiply them. I am going to multiply what's on top, though. 2x times x is 2x squared, and 2x times 1 plus 2x, right? Don't forget that you're distributing into each of those pieces, yeah? So then it's minus, well, I'll write it like this. 2x times x minus 1. No. X minus 1. Okay, so then it's minus, I'm going to distribute this. So it's 5x minus 5 over this stuff. Yeah, you can if you want. Yeah, it's okay. What do you mean? Like, can you cancel them? No, you can't cancel them. Here's the reason you can't cancel them. You can only cancel factors, like whole factors. 2x is not a factor. It's a term that's attached to this whole piece, right? So you can't just cancel pieces of a factor. You got to cancel the entire factor. But we are going to combine like terms here. I'm looking at what's on top. I'm subtracting now, right? 2x squared minus, is there any other x squared? No. So there's no like term for that. 2x minus 5x is minus 3x. And be really careful here. Be careful. You're subtracting all of this, right? Think about it like this if you need to. You're subtracting this entire thing. It's minus negative 5. What is that? Plus 5. Just be careful about your signs. So you have that over your denominator. Okay? Yeah. You forgot to distribute it into each piece. Yep, so I got to do 5 times each of those, and I got to do 2x times each piece of the other one. Okay? Nope, that's it. That's all I got to do. That's all we're doing. Does that make sense? Okay. Okay, let's do one more example, and then I'll be done talking to you guys. You'll practice for the rest of the time. Let's say you have one that looks like this. These denominators, are they the same? No. Okay, so when they weren't the same before, what did you do? You multiplied them by each other, right? Do you want to multiply these things by each other? No. Because you would have to do triple distributing. Nah, I don't want to multiply those together, okay? Yeah. Yes. If you find yourself multiplying together 2 trinomials, stop. Okay, don't do it. If you see one that they look like that, start by factoring. Start by factoring. Okay, so we're going to factor everything. This one, x squared plus 3x minus 10. You need 2 things that multiply to negative 10 out of 3. 5 and negative 2. Okay, and now this one. 2 things that multiply to 5 and add to 6. Don't overthink it. 5 and 1. Okay, now that I've factored everything, I'm going to look at these denominators. These types of problems are like a little bit of a puzzle. The denominators share one factor, right? What do they share? They share x plus 5. Okay, so that's the same. In order to make them match now, you just need to multiply by whatever the other one's missing. So you're still going to multiply them by each other, right? So what do you need to give this one in order to make it match? X plus 1. What do you need to give this one? X minus 2. So I'm going to run out of room here. I'm going to multiply this one by x plus 1. And I'm going to multiply this one by x minus 2. Just give it the piece that it's missing in order to match the other one, okay? So again, I'm not going to multiply the bottom. I don't want to multiply all those out. But I am going to multiply what's on top. And we need to be careful that we distribute into each piece, right? So what's on top of this one? 3x plus 3 over this whole thing, x plus 1, x plus 5, x minus 2. Okay, it's plus this. I got to distribute it. It's easy because it's 1. X minus 2 over that whole thing. x plus 5, x plus 1, x minus 2. Are these denominators the same? But they're out of order. Does that matter? No, not when you're multiplying, right? As long as it's the same 3 factors, you're good. They're the same. Doesn't matter the order. So the denominators are the same now. So we can just combine like terms. And we're adding, right? So we don't have to worry about the double negative thing. 3x plus x. Go away. 3x plus x is 4x. And 3 plus negative 2 is 1. It's 3 minus 2, right? Over that whole thing. X plus 1, x plus 5, x minus 2. And we're done. Does that make sense? All right, so I know you're always going to multiply them by each other, but if it's a trinomial, factor it first, see which factor you're missing on each side, and multiply by that factor. Does that make sense? So then you don't have to multiply some trinomials by each other, because that sucks. Nobody wants to do that. Go ahead. Have fun. Yeah. Does that make sense? Okay. This one it's the same thing except we're subtracting, right? So you just got to be careful about subtracting everything on the other side. Okay, I want to give you guys some time to practice. You got like 8 minutes left. So just try to get one of them done. Just try to do one of them. If you can do more than one, great. So factor everything. And then you got to give some factors where they need to go.